Good evening, everyone. For day 3 of Cyber Rakshak Beginner program, we'll be starting at sharp 6 p.m. Indian Standard Time. Good evening, everyone. Welcome to the third day of Cyber Rakshak Beginner. This is a proactive cyber defense engineering using Python, which is taught by us here at Cybervidyapeeth Foundation. And this is in association with All India Council of Technical Education and the Computer Emergency Response Team of India, CERT-In. It's a great pleasure to have you all here today with me. So we are going to continue right off from our last class. Please note that the attendance form will be shared with you guys soon. Once it is shared, if you do not fill it, you might not be invited to the next session. Okay, because this is the third session and this is the fourth time, counting the day one repeat session which happened for a few people. This is the fourth time I'm telling everyone to fill two forms that we have, which is the training entry form and the attendance sheet form. The attendance sheet form will be shared soon in the chat, both on Telegram and on the YouTube live chat, as well as the training entry form, right? Both of them are going to be shared to you. If you have not filled any of these forms, please go ahead and fill the forms. Make sure you take your time, take 5 minutes, but fill the form properly. Do not put wrong information. We don't want any issues coming up in the forms later on for our end. With that, let us begin today's session. We have a lot to cover today. Okay, so let's begin. I'm going to share my screen now, and you should be able to see it in just a few seconds. Perfect. I can see that you all can see it now, which is exactly what we wanted. I can still see some people talking about Teams. I don't know what you guys have been doing. If you've been following us on Telegram and on YouTube, then you know that we don't use Teams anymore since last 48 hours, probably a little more. So we've given up on Teams. We now only use YouTube. So this is the only link where you can watch. Please make sure that you are informing that to your friends if they're also doing this course, that they can only watch the course on YouTube. I repeat, you can only watch the course on YouTube, and you have to subscribe to our channel. Otherwise, live chat will have a lot of issues. You won't be able to put your questions properly, and it's harder for us to track your questions. Okay, so please subscribe to our channel, and while you're on it, press the bell icon and like our stream so that we can bring you more free content related to cyber defense engineering and ethical hacking. With that, let's go ahead. So as you might remember from the last two classes, this is the handy dandy hello.py file, right? This is the same file where we have been coding since last 2 to 3 days. Now, what I want to introduce you to today is a very special concept here, right? So what I'm going to do is I'm going to take you to the PPT, and I'm going to start the slideshow so that it's easier for you to read. And perfect. So now you should be able to see this slide that we had stopped at yesterday. And we had discussed almost everything here except the membership operators and the assignment. I'm pretty sure we also, did not discuss the identity operators, but there's a reason I'm not talking about them. So the identity operators and the membership operators are two things I am not going to touch until we cross day 15, because that is when you will actually use them in your programs. Before that, all the projects we are going to give you, you're not going to use them. Okay. And the second reason is they are slightly more advanced operators that are for now not required. Okay, I repeat, that are for now not required. But assignment operators are something that we need to have a look at. So let's go here and let's have a look at assignment operators for a few minutes. So as you can clearly see, assignment operators are used to assign values to variables. Okay, that's simple enough, right? If we look here, we can see that the operators are equals to, plus equals to, minus equals to, star equals to, or multiplicative equals to, division equals to, mod equals to, floor division equals to the power of equals to, and bitwise and equals to, bitwise or equals to. So these are bitwise symbols. If you remember these symbols from our bitwise learning, these are the bitwise symbols. Okay, so these are all the different symbols that we have here in the assignment operators. And the way they work is pretty simple, as you can clearly see in the example diagram in front of you right now. If we say x equals 5, that's it. That's literally what it means. It means that the 5 is a value that is put in a box whose name is x. Okay. X plus equals 3 means x is equals to x plus 3. What this means is that take whatever was inside the box named x, increase it by 3. So if there was a 1 bag of peanuts inside the box x, increase it by 3, so it becomes 4 bags, and then put those 4 bags back into the box called x. Hence, if x was equal to 1 initially, now x is going to be 4. Okay, so this is how you know that the x equals to x plus 3 behavior. So a similar behavior you can expect from all of these operators. Okay, x minus 3, x into 3, this is exactly how they work. You need to have initial value of x. Once you do, you can actually do these operations on this. Okay, so let me show you the live example, because again, you know me, I believe in real coding. So let's get our hands dirty and let's try to see this in live. Okay, so I'm going to do something like x equals 10, right? Because I love the number 10. It's easy to play around with. And I'm now going to do x equals x plus 10, right? I'm going to save the file. Then I'm going to add a print statement, which just prints the value of x. That's it. I'm going to save the file again and run my code. And if my PowerShell behaves properly, we can see the value 20 right here. Okay, I can see there are some questions. Exactly. Good job. I can see a lot of you have been able to do it. So, I'm going to make it a little harder now. I want to see if you can do floor division, which is the first interesting point. So just give me a second. Some people are telling me there's an issue with screen share. I'll stop sharing and share the screen if you can, so that you don't have any issues. Okay, so now you should be able to see my entire screen again, and there should be absolutely no issues. If you have any issues, please feel free to talk about them. Okay. Cool. Let's go ahead. So we can see we got 20, which means we took the value 10 and then we added 10 on top of it, and then we stored it back into x. Let's make it a little bit more complicated, right? Now I'm going to take whatever's in x right now. I'm going to do x minus 3. Then I'm going to do x equals to x. What's the next symbol? Into 2. Okay, so whatever was in x after x minus 3 is now being multiplied by 2 and then getting stored again in x. Okay, I'm thinking that all of you are getting me. If somebody is having confusions, okay, I have doubts related to bitwise operator. Can you please show that again? Sure. Let me complete this example. I'll go through bitwise one more time. Okay. I'll quickly show you the bitwise code once more. Bitwise has to do with binary. Okay. If you don't understand binary, I would recommend learning binary and converting your numbers from decimal to binary first. Once you know that, then bitwise is very easy. So moving on, I'm not going to print the value here. I can see people are writing the answers. I never said I was done. Okay, the final value of x is what I want from all of you. So I'm going to keep adding operators. Let's see how far you can calculate. So it's going to be x divided by, say, 1.453. Okay, then I'm going to make it intentionally tough this time around. So then what are the next operators? Could somebody quickly type in the chat what are the next operators that you can expect? Perfect, good job. It's the floor division. There's a name for it. Okay, it's called the floor division. So you have to do x 2 slashes and then the exact same number. So I'm just going to do 1.11. So I'm a small number. I don't want a large number right now because I know that -3 into 2 actually gave a pretty big number. So now what I want to do is I want to apologize. My throat is not feeling as good. There we go. So we will take it up a notch again and we'll add the modulo operator. So which is x modulo. And what do you want the number to be after modulo? Do you want the value of pi? It's going to make it very interesting if you add the value pi here. So let's go 3.14, okay, which is technically not the exact value of pi. So whenever I feel like getting the value of pi, I just type in pi, right? And Google will give you the exact value of pi. So let's just go ahead and paste that in. There we go. Now we have the exact value of pi. Now I'm going to take the value of x again, okay, and whatever was in x, I'm going to raise it to the power of 10. Okay, now I want you to tell me what is the answer. You have 10 seconds. I'll wait for 10 seconds. If you're coding alongside me, then 10 seconds is all you need. If you're not coding, try to do it on paper. It's going to be a little hard, but if you're good at mathematics, then it should not take too much. So 5 more seconds. There we go. I run the code and the answer is this number right here, right? So what I do recommend is once you have Anaconda or even normal Python plus VS Code installed, you code with me. Okay, I can see some people are confused. Please code with me, okay? Because if you're not, how will you understand? You have to type code yourself to understand what I'm trying to achieve here. Okay, so we get 2114.859 something, right? It's a huge decimal number. We got that accuracy because x became a complex double when we instantiated it with such a big modulo operator. So this is what we call assignment operators, okay? And each of these have a short form. So what I can do right now is I can actually do all these same things like so. So if we go back to our PPT for just a second, we can see that I did the normal way of doing it, right? And I still didn't do some things, but that's completely fine. Let's first understand the structure. Once you understand that, it won't be a problem. I didn't do the shorthand, which is actually what assignment operators are all about, right? So let's do the shorthand. So x plus equals to 3. Okay, so I'm going to do x plus equals to 10 because that's what I did originally, right? Then x minus equals to 3, right? Then I'm going to do x. What's the next operator? Let's go with multiply, divide, modulo. Yeah, same thing. So x multiply equals to 2, right? x divide equals to, I'm pretty sure that's correct. Yes, that is. It's okay to confirm. Okay, see, because I don't want to teach you guys the wrong thing, so even I'm going to confirm my code every time I run. Okay, so x is floor division. That's what we did next, so I'm going to just go with floor division 1.111, and I have to add a equals to sign here, of course, because this is the shorthand way of doing it. Then we have to do x modulo equals to, and this huge number, this massively huge number. Then we have to do x star star equals to 10. Okay, so I'm going to save and run, and we get 131.216. Okay. I can see some people are fighting with moderators. Please don't do that. Okay, see, the stream is working completely fine. Okay, we are testing it using 7 devices here, all on different networks, so we know exactly how the YouTube thing is responding. Okay, the YouTube server. So please don't, cause confusions. The stream is working completely fine. If there is an issue, it's probably on your end. Okay, so just make sure. Also, some people have been complaining that they aren't able to access their Anaconda or their normal Python environment. To them, I would like to just tell them to go to extensions and install the Python environment manager. Once you have this, you will actually have a button here which says select interpreter at the bottom right. You can click on it and then select the path to your interpreter. In this case, I'm using Anaconda, but again, it's not required to use Anaconda. It's just something I'm using to teach you guys. Okay, so let's move ahead. Let's not waste too much time here. So these are the assignment operators. Now I know there are more, but there's a reason. If I teach you everything, what will you learn on your own? So the remaining 4 assignment operators, I want to, you guys to do as home. I want you to go home and code them yourself. Okay, I'm not going to show them here intentionally. So with that, let's move on to our next topic, which is control flows. Okay, so before I go too deep into what if-else statements are, what control flows are, for how for loops work, etc., how logical statements help, I want to, tell you about a simple incident. Say that my mom gives me a shopping list, right? A grocery shopping list. She tells me, okay, this is the list. You have to follow this. Get me this groceries by the end of the day. Okay. And on top of that, she adds another list. She says that, okay, this is the main list. You have to complete all the things in this main list. Inside of one of these points in this main list, there is a point which says buy groceries. When that happens, you go, you buy groceries. So it's like she gave me a bunch of instructions of what to do with my day, right? Because it was Sunday, I was free and I was helping out my mom. I said yes. So in the morning, I went and I, I took a lunch box to my brother, right? After that, I came home and I cooked breakfast. I cleaned my room. I cleaned my mom's room. I then bought some fruits for the house. Then I saw that there was an instruction about buying groceries. So I followed the instruction and opened the grocery list. Then I went out and bought groceries in the order that it was mentioned. Then I came home and delivered the groceries, and I repeated this process until I was out of instructions. When I had no other instructions left, then that is exactly when I realized that, okay, my work for today is done, right? So I can go to sleep, because it was something like 11:30 or something in the night by the time it was done. So that is similar to how we'll try to model our control flows. Control flows, what does that word mean? You try to control the flow of your program. Okay, but how? The question that arises, why? First of all, leave how. Why would you want to control the flow of your program? Say that you have a program that is able to calculate how much marks you get based on every mistake you do in your paper and every right question, every spelling mistake, and every format error, okay, that you do in your online test. Say we make a Python program that can calculate for a such a program that totals your marks. How is it deciding what to do next if you miss a full stop, or if you miss a what is what is a comma or what is a semicolon? How does it understand English structures? Have you ever thought about it? Does Python already know all this, or have or you have to actually go ahead and code all this? So the answer is the last one. You have to actually code all this logic, and this logic of what decision to take whenever there is a decision to take, right? Say I get up, I get out of this room. Should I take a left or should I take a right? Two decisions. Okay. If I take a left, should I go to the washroom or should I go to the kitchen? Two decisions. I come back to my room. To come back, I need to look behind. Two decisions. Should I look behind towards the door? Should I not look behind towards the door? Once I have looked, should I walk towards the door? Should I not walk towards the door? So one concept that I want to clear for all of you is that everything in life, okay, is binary in nature. The most fundamental of decisions our brain makes is actually binary. It's either yes, I'm going to do it, or no, I'm not going to do it. Yes, it's true. No, it's false. 0 or 1. Okay. Everything is binary in nature, and a similar feel you'll get here in control flows. Because as we'll explore deeper and deeper into control flows, you'll realize that every logic can be broken down into two choices. And that is how you take control of your program. Say your program wants to find out if a number is even or not. Before it even goes into that code, you decide, do you even want to do that? 0 or 1, yes or no. Okay. So everything in life and in coding is binary in nature. That's the first concept I want everyone here to understand. Exactly. To do it or not to do it. To pick up your phone or to not pick up your phone, to eat food or to not eat food. Every decision you take in life, okay, no matter how fundamental, is binary in nature. And this is a mind-boggling concept when you think about it, because your brain, the most powerful computer in the world, is able to do these micro decisions without thinking, like subconsciously, right? When you get up from your bed, your brain took the decision for getting up from your bed, even though it was a binary decision. And your brain can chain millions and billions of such decisions in a day as if it's not a big deal, right? This is why we still say that human brain is far more advanced than we realize, right? So we try to mimic the human brain in programming wherever possible. And this is one such area where we try to mimic the human brain. The entire control flow structure in every programming language, starting from the early days of C language, Java, and even Python, has been modeled after the human brain. Okay. And to understand this further, I'm going to read from the PPT because there are some really good lines here in this. So it says, and I quote the PPT, there comes situations in real life where we need to make some decisions. And based on these decisions, we decide what should we do next. Similar situations arise in programming also, where we need to make decisions. And based on these decisions, we execute the next block of code. Decision-making statements, I repeat, decision-making statements in programming languages decide the direction of the flow of program execution. Okay, so this sentence is a little technical. Those who did not understand it, I'll break it down simply for you. Right now I said, right, to take a left or to take a right. You have two options, correct? You can either go left or right. This statement, should you go left or should you go right, is a decision making statement. And once this is executed properly, if you took a left, then the next part of your program, should I go to the washroom or should I go to the kitchen, comes into play. Not before. If you took a right there, then your code changes, then you only see a wall, right? Because if you took a right from my room door, there's only a wall there. So you only see a wall. So, then the next block of code would be turn back or to not turn back. So this is how kind of sort of programming works. I'm saying kind of sort of because there are some technicalities here. This is a very high level pseudo explanation of what goes on. So let's have a look at the first type of control flow that we'll have access to, which is the if condition. So the if and the if else are what you call as conditional branching. For those people who have trouble understanding what conditional branching means, imagine you are creating branches of trees, right? So if you imagine a tree, the tree starts at the root, which is always going to have hundreds and thousands of small nodes. If you've ever seen a diagram of a tree properly, a proper biological diagram, you'll see that the tree's roots have millions of nodes, right? Each of them branching off from one place to another. That is kind of how programming and even our human brain works. That is how we make decisions. We use the tree format. Okay. Now the tree format is a little bit more complicated, so we'll come to it in a later part of our journey. Not now. I don't want to get into trees and binary trees and non-binary trees right now, and linear trees and all that stuff. But just know that the entire Python language and the conditional branching, even in not just in Python, in all languages, it's based on the tree concept. So here we can see if some condition is satisfied, do something, else do something else. So to better see this in action, again, you guys know me already by now. I like to code. So I'm going to create a variable x which is equal to 10 and a variable y which is equal to x. Then I'm going to create a variable called z which is equals to y of x. Okay. So we have three variables now. Now here what I want to do is I want to have a simple condition. I'll say if x is equal to, this is how you compare. Okay, this is a comparison statement, equality comparison. I had taught you about this. If x is equal to 7, print first branch, right? Else, actually, yeah, this is actually completely fine. You can go with me. So else, I want x's value changed to 7, and then I want to print the value of x. Okay, so very simple program, nothing too complicated here, right? I'm going to give you guys 60 seconds. Quickly tell me what's the output of this program is going to be. Okay, so it looks like a lot of you got it, a lot of you didn't. So let's try to have a look. So my screen should be visible now. So what we basically did here, we said that if, okay, if I speak in Hindi, agar, okay, x is equal to 7, अगर x 7 के बराबर है, यानी कि x के अंदर जो वैल्यू है that is equal to 7. Okay, so if x, whatever value the box x contains is equal to 7, do whatever is in this line, else do this. So we got the output 7 here, which tells us that x was not 7 clearly, right? This is a very simple statement, right? I'm going to make some more changes to the statement. I'm going to change this x to 10 now, and I'm going to save it and run it. You have 5 seconds to tell me the output. 5, 4, 3, 2, 1. There you go. I'm going to run the code now. I can't see any outputs. The reply is going to be first branch, right? Because the if statement is now getting executed. Okay, so we get first branch here, which means that if statement was now executed. So other than if and else, we have something else here called elif, or you know, in other languages called the else if. I don't really like this term elif, so I always say else if, which allows you to have another if condition after your original if, and it works kind of like this. You can say if x is equal to 7, okay, print third branch. Okay, okay, some people are asking questions. Just give me a sec. Okay, interesting. So what I want to know is what will be the output of this program. I'm going to save the program. What will be the output of this program? Simple question. First branch. People are saying, you know, the output is going to be first branch. First branch. Okay. So third branch. Some people say it's going to be third branch. First branch. First branch. Okay. 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 Interesting. First branch, then error. 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 First branch, then error. 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 So you have to give me the system error. Okay, no, that's never going to happen with Python. Definitely not system error. Okay, so let me just run it, right? Welcome to your first error, right? Because you notice here something interesting. And I'm going to clear the context for you guys. It's just file f courses AICTE1 hello.py at line number 10. Elif x equals 7, syntax error, invalid syntax. So here we are learning three things. One, Python can tell us at what line the error has occurred. Two, it knows exactly where the error has occurred and it shows that line to us. And three, it has specific name for specific errors. For example, for this error, the name is syntax error and it is an error I've done intentionally. So now my question is this: how do we fix this error? Think. You know, if you're a programmer, you're going to come in situations where you are using others' code. You're going to have to modify the code to use it for yourself, add features to the code. So you need to know what to do. Okay. Yes. It looks like you have got it. So what we need to do is we need to copy this statement, which is the else statement. We need to remove it and then do this. And now notice that there's absolutely zero errors. And if I run this program, we get the output first branch, which was, I mean, it was pretty clear, right? Because we have defined x equals to 10. So now I'm going to make it even more fun. Who wants to have more fun? Okay. I'm going to introduce another function. Okay. Now, for now, you can think of a function as a magic statement that does some magic. Print is a magic statement because it prints something. Just like print, there is an opposite magic statement that does the exact opposite of output. It takes input. I'm going to save it and just run the program. Now what's going to happen is, if I show you guys properly, notice that the cursor is blinking when the program executes, and it's actually waiting for me to enter an input that is transferred into the box named X. So I'm going to just go ahead, copy the value of pi and paste that in here. Okay. Does anybody have any issues with that? If you do, please go ahead and ask the question. Okay, no issues. Then I'm going to hit enter, and there we go. We see an error. Our second error. It's a very simple error, but it's an error that people miss. And honestly, even I missed right now. So let's again read the output. Okay. File in line 3. Okay, so find line 3. Line 3 is Z. That is confirmed. Okay. It's giving me Z equals to y to the power X. Type error, unsupported operand for power or pow. Pow is the other name for this power. String or string. Okay, interesting. So let's understand what just happened. As I had taught you guys before, there are different data types. So if we go back here, there are different data types, right? Oh, it looks like you can't see my screen. I apologize. Just give me a second. Yeah, now you should be able to see my screen. So as you remember, there were different data types, right? So the top, there was a text data type. The only text data type, str, which stands for string. That is where the interesting thing has happened. We forgot to convert the value of x from a string to a number. And it was completely fine till x and y. But when you try to do an operation that can only be done on numbers and not text, okay, you can only do something to the power of something on numbers, not your name, right? You cannot do Ayush to the power of Krishna, right? That doesn't work. But you can do 3 to the power 4. So that is why this error came. So let's understand how we can fix this. So a really easy way to do this is to convert the input to an integer immediately as you take the input. So you just have to type int and wrap the input in brackets and save the file. Now if we run the program, it's going to again wait for my input. I'm going to give it the input, and it's going to again give me an error, and I know exactly why the error has come. If you see, we are saying here that, hey, I want to take integers, but I'm supplying something that is not an integer. So that means, okay, I need to refer to my PPT again, right? We have numeric types, int, float, complex, right? So it means I missed something. It was supposed to be not integer, a float. Why a float? Floating means decimal numbers. So I'm going to type in float here, save the program, run it again, paste in the number again, and boom, this time it works, right? This time the processing works and we get the output 7. So what exactly happened? I want to, follow along the code. So to do that, I am going to do a dry run right now with my own mouth. So first we will give the input with a huge value of pi, which is converted to float and stored in x. Then that value x is given to y. So x and y are exactly the same. This sentence basically means that x is equals to y. Then z does the following. It takes the value of y and it puts it to the power of x. Then we check if x is equals to 10. Now it's pretty clear x is not equals to 10, so it doesn't run, right? And this is going to be second branch. So then we are pretty sure that x is not equal to 7 as well, right? Because let's be realistic here. If you do 3.14 something something to the power of 3.14 something something, it's not really going to come as 10 or 7. So we come to the final else statement, which is the last conditional statement here. And we say, okay, x should be equal to 7. If none of this is correct, make it equal to 7. So delete whatever value you had in x, overwrite it with 7 and print x. Hence the output 7. Okay, you could make it much more interesting. You could do something like modulo equals to 2. Let's see if you guys are able to tell why am I doing this. I had explained this before. I'm going to paste, and this is the output I get. No, that is not correct. I am audible. Please don't write wrong messages in the chat. Check your audio on your system. So can anybody tell me what I just did here? You have 1 minute to reply in the chat box. I'm looking at the chat box right. So somebody just said that it checks, the strict checks if the number that I have inputted here is even or odd. So tell me, after looking at this output, 1.41459265359, if the number is odd or even. Again, I'm giving you 30 seconds to decide if the number is odd or even. The number 3.14, is it odd or is it even? Okay, so I can see a lot of people writing odd, which is interesting. So tell me, what would the remainder need to be for it to become even? It looks like some of you are actually running the code in the background. Huh? Good job, good job. Well done. Yes, you need to have remainder as 0 to check if the number is even or not. And we can actually test that, Let's just put a even number, something like that we know is even, something like 1024. Okay, clearly an even number. Okay, result too large. Oh, no, I apologize. You know what? I don't apologize because this is another interesting error right here. it tells me that when we increase it to the power of y to the power of x and store it in z, we have an overflow because the resultant number is so large that I just can't store it. That is actually talking about limits of numbers. Okay, so 1024 to the power of 1024 is actually a huge number. It's not a huge number, it's a huge number. Just to give you an example, okay, just to make it a little bit more interesting, I am actually going to type Python here, get into the Python, sorry, not this, get into the Python interpreter by using Anaconda. So I'm going to just go to Anaconda, give it a few seconds. I want to manually show you this, how much the values can exponentially increase when you are having something to the power of something and the value is more than 1000. Because I know Python actually has issues handling large numbers and unless you customize it internally. But this is a nice lesson. This overflow error is actually something we can learn from. So let's learn from it. So I'm going to launch the PowerShell prompt. Now inside the PowerShell prompt, I'm going to zoom in so you are all able to see it properly. I'm going to type in Python. I'm going to get into the Python interpreter and I'm going to type print, and inside brackets I'm going to do 100 to the power of 2 to get 1000, right? I'm going to increase this to 200. Do you see what just happened? The exponential increase, right? I'm pretty sure most of you have studied exponents chapter, right? So this is an exponential increase. The increase in the data is insane. And it's so insane that if I add one more zero, Python's gonna have trouble computing those zeros and it's going to overflow. As you can see, zeros everywhere, right? So this is a huge number and I'm already very close to the limit of Python's breakpoint. As a matter of fact, I could demonstrate it to you by making it something like 200. So you can now see that we have a huge number. I mean, huge is an understatement at this point. Okay, so Python can handle some pretty large numbers. Okay, but the problem is storing them in variables is going to be really hard because you might not have enough memory allocation or you might not have enough memory space. For example, I'll do this exact same thing that we were doing there. So which is 1024 into 10, not into to the power of 1024. And here's the number. So look at this insane number. Okay, first of all, it's it's a number, all right. Okay, what happens then? Instead of printing it out, you do x equals to the number. Weirdly, we're able to save it here. Interesting, right? So let's try printing x and see what happens. We are able to print it. Even more interesting. Let's take it even up a notch. Let's do 1030 stored in the text and print it up, and we are still able to store it. So if we are able to store it here, let's go back to our program and try to understand what the issue is. It says overflow error, result too large, but is that true? Is that really true? Think about it. Because just now I showed you insane numbers. Like at this point, we're playing with numbers you can't even count in English. Okay. So what is going on? What is the error here? Why is there an overflow error here in VS Code? The first person to find this is going to get something, some good surprise from. And I'm noting down all the names who answer. So figure out what is going on here. And remember, the error is in line 3. Okay, so you can actually see the line 3 right here. All the 11 lines are visible to you and the error is visible to you as well. And it says overflow. when storing in Z, but that is not possible, right? Because see, I just did it. I just saved it. If you want, I'll increase the number even more and print X again, just to prove my freaking point. There you go. It works. Python can handle that much numbers. It can store it in a variable. Then why is it not working? Finally, someone has answered. Good job. Good job. Because the float data type has higher memory than int. Exactly. So what's happening is that we are using float here and X becomes float. And because we are saying Y equals to X, Y also becomes float. But when you do this operation, by default, you are working on integers. And there's a limit to how much data float can handle. We are touching the limit. Here we are not touching the limit, because notice what I'm doing is this, right? I'm doing X equals to something into something. I'm never telling the system what data type to choose. So automatically Python is choosing the largest one. Correct. Here that is not the case, because the power function or the power function is being called. So you need to understand that these shorthands are actually calling functions and or special words, as I have not taught you functions till now. Special words like print and input. One such special word here is pow, which stands for power. And this special word simply cannot handle such large numbers if you're dealing with floats. So now you know weakness, okay, of Python. Let's exploit that even further. We are hackers, so let's play around with numbers even, because see, if you going to be a hacker and do buffer overflow attacks, you need to know how to make huge numbers. So what I'm going to do is I am going to convert all this into a float and store it in the variable, and now we get the same error. So now you understand what was the issue. Integer too large to convert to float. It's the same error, overflow error. See the name of the error, same error. So now you understand what happened. If you were dealing with integers, it would have not been an issue. So the way to bypass this error is very simple. We'll have to drop the additional data, or we'll have to use long float, but I'm not going to long float doubles and complex numbers right now. So what I'm going to do is I am simply going to, first of all, down here and just do a simple int y and do an int, super simple solution to handle the issue, and then just give it 1024 again, and this should work without any issues. 1024 gave us 0.0, right, which is remainder is 0. Okay. Some people are saying remove float. No, we will not do that. See, whenever you are making a program, make it as generic as possible. What you are telling me to do to remove float from the top is not going to work, because when I run the program and I put something like 3 point something something something, say for example 3.0000001, then your program won't be able to handle it. So always take input with float on. Okay, you will see most game developers, when they're making games and they're coding for games, actually they always use float for input. So if you are putting coordinates of a player shooting someone in CSGO or PUBG, right, that data is actually getting stored in a float variable. Okay, so if you learn game development, you'll learn that float is actually used a lot more than int in the industry, because you always want precision and accuracy. And double is not used as much, because the more you use double and complex numbers, the more you're going to use the RAM. Float is much more optimized than something like double or complex or long float or long double. Okay, so these data types usually we like to stay away from, and we always take input in float. This is your first lesson. Whenever you're whenever you're taking in numbers from the user using the input magic words, which is right here, I've highlighted it for you, make sure to use float outside it, especially when dealing with numbers for the time being. Okay, this is going to make your work easier and conversions later down the line even better. So with that, some people are still asking me what happened. Okay, fine, I'll show you one more time. Say I'm doing x is equals to some insane number. I feel like just putting like a huge number here. Okay, so this is, huge is an understatement at this point. So I'm going to do print. God help me for what I'm about to do. Wow, that's a big number. Let's try scrolling up. Oh, wow. That's a big number. Let's make some changes into that number. So okay, you want me to explain that again? Okay, cool. Say that I do 314 to the power of 1024. This is simple maths. If this will not work like this. So I need to do the print statement. So if I do this, this is the output, right? 314 to the power of 102. You get this huge number. Okay. Huge is an understatement. Okay, it's ludicrous at this point. Now what I did was I took that value, and this is an integer. Okay, remember this is an integer, meaning it's a whole number. I store it in X, then I print X. I'm going to show you why every data scientist and every other hacker uses Python right now. You print the number, so we know that the value is stored in X. Now I said that I want to create a variable Y which stores the same value but as a float. Float means I want to convert the number to a decimal number. So for example, let me open Notepad, the oldest editor ever to exist. Say that I'm storing 1024. This number exists inside X. Okay. I am doing Y equals to float X. Okay. Now what's going to happen is it's going to take 1024 and convert it to 1024.00 and then store it in Y. But the problem is this is not going to work because float as a data type simply cannot handle so much data and the program crashes. Now I want you to think like hackers. What happens if somebody takes data in float and you bombard them with a huge input? Think like a hacker. Okay, what happens when somebody has a website taking data in float, a website made in Python, taking data in float? You bombard them with whatever number you can see in front of you. What happens then? Does their website crash? Buffer overflow? Not really. It's not just a buffer overflow because Python doesn't stop. Exactly, it's a DOS attack. It's a denial of service attack. We crash their server. Exactly. Now you understand. Okay, so all these mathematical concepts that we're studying, okay, maths is a beautiful thing because once you start getting into it, you realize a single number, a single value, right, can cause havoc. And we'll make our own web server soon, and you will see the crash live towards the end of the course. So I'm going to exit out of my shell here and my terminal, if I can type exit properly. Thank you. I'm going to close this up and we are going to take a break of about 30 minutes from this point onwards. Okay, what I want you guys to do is, if you have some food, maybe some snacks, wash your faces, have a calm mind, clear your head, come back here, and we're going to code some more. I'm going to show you some more complex situations where numbers can be interesting in Python and how hackers use them to cause issues. And as far as data types are concerned, you don't have to remember all the data types. Okay, as and when you program, slowly you'll come to learn all the data types. So for now, I'm going to just share this slide only, and take a half an hour break so that you guys can also get some rest. You know, if you want, you can read through and memorize these data types, because this will help you so much. And once I'm back, we'll go much more deeper, and I'll show you some other data types and how to break those data types. Because, you know, as hackers and as cyber rakshaks for Bharat, you know, our goal is to both break and to defend, you know. So we need to learn both sides of the coin. So with that, we'll take a break, and I'll see you guys when I come back. It's a 30-minute break. Okay, welcome back, students. Why are people writing president, sir, in the chat? Okay, you don't need to write present. Okay, you just need to just go ahead and there's a pinned comment. Inside that pinned comment, you'll find the attendance form. Just fill that form, okay? And you'll be perfect. Is my voice clearly audible to everyone on YouTube? Can you just say that voice is clear? Just drop a text. Perfect, perfect. Okay, so my voice is clear, so we can move ahead with today's learning. Okay, so let's start. So 101% clear. Okay, nice to know. So now what we're going to do is, now that we've seen some interesting things about data types, okay, and control flows, I'm going to, so this is the next topic, right? Looping. But before getting into looping, I want to show you two very interesting examples. Okay, so here's the first example. Tell me if you like it. Okay, what I'm going to do is, I'm going to type D is equal to 1.01. Okay, E is equals to D into 0.314. Okay, A is equals to D and E is equals to D. You have 10 seconds. Tell me what E contains. 5, 4, 3, 2, 1, 0. I do not see any output in live chat yet, at least. So I'm just going to show you the output. 1.01, exactly. Good job. So I'm going to increase the complexity now. Okay, I'm going to make the questions much harder for you. A equals 10 to the power 100. I'm going to put this in a bracket, so this becomes its own code block. Minus 20 plus, inside brackets, I'm going to do 1024 floor division by 3. And I'm going to do a normal multiplication with 7. What is the value of A? What will be the output of this code? You have 5, 4, 3, 2, 1. You guys, what are you saying? 3367? No. 3367 is definitely not the correct answer. Look at the answer here and tell me, how did I get this answer? First of all, what did I do? Here I'm not defining anything such as float, double, whatever. Okay, I get a very big value, yet some people are writing 3367 for some reason. Look at the brackets. Okay, do you guys remember? First of all, I need to ask you guys this. Do you guys remember this back in school? Om Kumar has got the correct answer. But do you guys remember this at school? Okay. So how does this work? You have, first of all, work line, also known as work line. Then you have also known as bar, actually, in many places. Then you have brackets. Then you have off, which is basically multiplication in normal mathematics. Then you have division. Then you have multiplication. Then you have addition, and then you have subtraction. Right? Am I clear to everyone about this? If you have any questions about this, first of all, please go ahead and just answer me. Okay. And work line is that bar you put on top of a number. So for example, this number 1000000 something, if it had a point. So for example, you could have said something like, it's actually really hard to show you that here because I can't really make a bar. So instead say that there is a number 3.3. Okay. You can also write it like so. This number, okay, is an example of work line or bar. Okay. Which basically means that this 3 is going to continue infinitely. Okay. So this is first, then you go with all the brackets. The brackets, I think you guys already know, which is the smallest bracket, which is the middle bracket. So the smallest bracket is, yeah. So the smallest bracket is this bracket, then you do this bracket, and then you do this bracket, right? So this is how it works. So, these are the 3 brackets: smallest, bigger, biggest, right? So now brackets work. Off really doesn't exist in programming. You have to use multiply. So then you have division, multiplication, add, and subtraction. So BODMAS, remember, there is a V in front of BODMAS always, which is always silent. That's why we say BODMAS. It's not BODMAS, it's VBODMAS. Okay, especially when you're doing college study, you'll be taught this. So okay, leaving that aside, now that we've seen this code, and this code is doing something very simple. Okay, it's first executing this part and this part. The reply from these two parts. Okay, and actually, you know what, I'm going to make this even more interesting. I'm going to show you how it's executing it. So for that, I'm going to download a software. Now you don't have to download this software. I repeat, you do not have to download this software. I am doing it to teach you guys. Okay, the name of the software is Thorny. Okay, so I'm just going to search for Thorny, which is a Python IDE, integrated development environment for beginners. I'm just going to click on the Windows icon and download the recommended version. And then just for some reason, why is it so? Yeah, okay, now it's downloading very fast. So just give me 1 second while it downloads. So now it gives me 2 options: install only for me, install for all users. I'm just going to install it for me. Just to next, create a desktop icon. That's completely fine for now, because I'll be installing it after this after this tutorial. Thorny is a IDE, my students. It's a Python integrated development environment for beginners. It is similar to VS Code, but it's not as powerful. But it has one very interesting feature called step into code, which I want to show you guys. Just for that code I'm installing. I'll remove it after. There we go. We finished it. Now I'm just going to look for Thorny and run it. Again, you do not need to install Thorny. I repeat, you do not need to install Thorny. Okay. So I'm just going to do a let's go. It's going to launch Thorny. I'm going to go full screen. I'm going to zoom in a little bit. I'm going to my VS Code and just copy these 2 lines of code, paste them in here. Now here I can do just give me a second. I apologize for the delay. So what I did here was, first of all, I saved the code inside a file called test.py. Okay. Then I just clicked right beside A to make sure there's a red dot there. I'll explain what the red dot is in just a second. Okay. Then what I'm going to do is I'm going to go to run. Okay. So I'm going to save the program and I'm going to go to run current script. The moment I do it, you will see that there is a massive output being given to you, right? This is basically what is happening is that when you're running the current script, okay, it is going through. Okay, what just happened? No, this is definitely not the. Is this the new version of Sony? Did they change it? Okay, doesn't matter. I can do the same thing here. So I can just put a over here, put a breakpoint, and then run it. And it's going to execute it. Okay, so the execution environment does not support the debug right now. So if I want to debug it, I have to show it to you manually. Okay, completely not an issue. So okay, so I'm going to just show you manually because there's an issue with you know what's going on with Thorny. So here's basically what's going on. First, the brackets get executed. So this bracket gets executed. So let's jump into a Python environment to do this manually. So I'm going to launch a PowerShell here. So it's easier for you all to understand what is going on. And in here in the zoomed environment, I'm going to open Python and I'm going to type 10 into not into to the power of 100. I'm going to store this into A. Okay, just for my safety, I'm going to store this into A. Then the next bracket is going to go into B, which is 1024 floor division 3. Then we do multiplication. So the floor division value B is multiplied by 7 and stored in C. Okay. Then the value of C is added to 20. So we have to add C plus 20 and put that in D. And then finally, I'm going to go ahead and then finally, I repeat, and then finally, I'm going to take the value of A and subtract it from the value of D. So A minus D. Okay, and I'm going to print that out. If my mathematics is correct, okay, what did I miss? Okay, so the floor division round off is what I missed. 1 needs to be added to this number. So if I add plus 1, what is the issue with the brackets? Perfect. Okay, so I'm doing something wrong here. Let me see the script again. We know for a fact that the brackets execute first, so definitely this is the first output you'll get, right? Then you do the floor division. Yeah, this is completely correct. The brackets execute first. Anything inside the bracket executes first. So let's. Oh yes, it's gonna be C minus 20, not 20 minus C. Exactly. That's why. You know what? Mathematics, right? Okay. So in this script, what is going wrong? I want a one statement answer. Okay. Now that I have understood what I did wrong, I want to see if you guys have understood, because I can see 4 or 5 people replying. There is yes, there is a debugger here. People are asking, is there no debugger inside uh, VS Code? You can install and configure. Exactly. So there we go. Sahil has given the right answer. You need to minus 20 and then add C into the answer. Correct. So yes, to answer your questions, there is a debug Python file option here, which lets you run the debugger. Okay. And lets you stop the control flow of the program. So right now that's not really going to work because we are immediately getting the output. But say that if I have a line of code at the top which says something like b equals input, okay, and then I save and then I try to debug the program again. What the debugger does, it gives you real time data about variables and the call stack, which is basically the memory. So I could actually go ahead and type here 3000 and hit enter. Now it's going to exit the program here, because again we are just executing these two codes. But if we don't exit the program and have an infinite loop, it's actually going to show us the variables on the stack and all the data and how it's been pushed. So a built-in debugger does come with VS Code if you're into it. I rarely use the this debugger, honestly, because even in most complex programs, usually I can just figure out the problem and solve it by myself. So doesn't really matter that much to me. But if you're having issues, you might want to use the debugger here. Also, you can stop the program execution in the debugger at any line by clicking just left towards the line number, where you can set a breakpoint or the point where the code needs to stop. So for example, you can have a equals input, and then you can have b equals 10. Okay, and then you can set a breakpoint here at b, and then you can have some print statement here which prints something like test. Doesn't really matter what it prints. And then you can save it and run this in the debug file. And if the debugger is launching properly, the code execution stops here at b. Okay, and you have to first enter file data. So I'm just going to enter 10. And now once you enter 10, you can see that 10 was stored inside a, and here inside local variables, you can see a:10 being declared, and it's technically global also because we're not using object oriented programming here. And on the call stack, we can see that in hello.py, in the standard module, we have our variable. Now say that you put another breakpoint somewhere here. Okay, so we remove the breakpoint and we put it somewhere here, and then we just go with the execution flow. It's going to, okay, I need to manually remove it. So remove this and this one. Perfect. And then I can just go back and do the normal flow, and then give a number and it will execute. Perfect. So this is how you work with the debugger. Again, I do not use debugger if I'm being brutally honest with all of you here. So because I do not play around with it much, I rarely you know use it at all. Okay, and one thing, okay. Yeah. So one thing you need to understand always, okay, with Python is that many times Python may have behavior that you're not expecting. Okay? When that happens, it's a good idea to run the debugger and look at the memory, the call stack, and the variables. If that doesn't help you, then there are plugins out there that can visualize execution. I remember back in the day, Thorny used to have a visualization feature. It looks like they've removed it or something, but that's completely fine with me. Okay, I can just figure out an extension and do it here in VS Code. Everything's in VS Code, anyways. So maybe next time, I'll show you some nice extensions. Thorny is not required to be installed. I repeat, Thorny is not required to be installed. I was just testing something. Please don't install it. Don't ask questions, unnecessary questions in the group regarding Thorny. Thorny is not part of the course. I repeat, Thorny is not part of the course. You can do everything in VS Code. You do not need Thorny. Okay. For extensions, some people, before I end the class, some people have been asking me, sir, I cannot find the Anaconda extension. That's completely fine. You just install Python Environment Manager, then you install Anaconda the normal way, and you will be able to select the Anaconda environment. A similar thing with most of these. Okay, so for example, Python indent, shades of purple, this is just a theme. You can have your own theme, but IntelliCode, for example, these the auto docstring generator, these are especially helpful. Okay, so just to give you an example, if I go down, okay, so let me show you this. Okay, so here in the file, what I'm going to do is okay, no, let's leave that because that is a part of 7th day. Okay, fine. I'm not gonna go into that right now. See, because I don't want to rush you guys into something that you're not prepared for. So let's stop today's class here then. Okay, we've reached almost 8. What I want you guys to do is make a simple program, and I'll tell you what the program is going to be. Okay, I'm going to share the homework here in the live chat, and you have to go ahead and do the homework. Please remember, I repeat, please remember that you need to do this homework by yourself. Do not copy or paste. If you do that, we will come to know. How we will come to know is not something you need to bother yourself with, but we will come to know. And when that happens, it's not going to be something you like. Okay, we will block you off, we'll remove you from the course. We can block you from our YouTube streams also in future. So please do not cheat. Okay, and I'm going to give you some really interesting, because I want you guys to brain sack your head with if else first. Okay, as and when we touch a topic, we'll worry about them, but for now I just want you guys to ramsack your head completely. And the project is the following. So I'm going to share a screenshot in Telegram right now, because this is a screenshot actually of my notes. So I don't want you guys to get it from any other sources. So what I'm going to do is I'm going to put it in Telegram. So you should be able to see it in Telegram right about now. Okay, this program right here is your homework. Can everybody see it? Where to submit? I'll give you the link. Don't worry about it. Did you first of all everyone get the image? Everyone got the image, right? Perfect. So now that you have your own image, I'm going to give you some more resources related to this. So first thing that I'm going to give you is an ASCII art image, and I want you guys to actually use ASCII art when printing out statements. So this homework is going to be a little bit more confusing. So I'm going to open my live chat and I'm going to send it to you guys. Just give me 1 second. There's my live chat. There we go. So this is the first link. This is the second link. Give me 1 second. Okay, fine. I think you should be able to do the program with just this much. Okay, so here's the link. I've shared the link both here and in the YouTube, the Telegram chat. Okay, so here's the Telegram chat. So these are the two things I'm going to provide you with. Okay, using these two, make a command line application using a Python script. No, there is no WhatsApp group. Okay, there is no WhatsApp group. I repeat, there's no WhatsApp group. Use these two to make a command line program, just like I have been making. Just write the code in VS Code, okay, and get me the results by tomorrow evening. This is a very simple program, okay. There is literally nothing here. There's literally just 7, 8 if else statements, but this will check if you understand if else properly or not. Okay, so please make sure that you follow this. Both the links and the image have been shared in Telegram as well, so you can go ahead and get them up from Telegram as well. Okay, so with that, we'll end today's session. Please make sure that you are completing this homework. You will be asked to submit this homework tomorrow. Okay, please make a new Telegram group. No, unfortunately that cannot happen. 6,000 people cannot move. Okay, so I've shared the one link and the image, okay, in Telegram. I repeat, in Telegram. Okay, I've shared an image and a link in Telegram. Use both of them together to make a Python script. Got it? Everyone understood? You have a bunch of steps. You need to complete those steps and you need to make the program. It's a very simple program. There's nothing there. It's all if else, if else, if else, if else. Okay, it's all, I repeat, if else, if else, if else, if else. Again, I repeat, it's all about print statements and if else. I'm literally giving you the answer. Okay, I can't say more. So please go ahead and try it yourself. I'll see you guys tomorrow again at 6. Hope to see you there. Dhanyavad. Jai Hind.